Hello everyone, my name is Renata. Welcome to the first session of my Magic's webinar series covering the most important aspects of systems and systems of systems modeling, model usage, analysis and simulation, and governance. Today we will talk about model lifecycle management. This session focuses on our vendor experience and current best practices addressing model lifecycle management. We'll demonstrate a scenario that reveals the significant challenges and issues faced in model lifecycle management. We use this scenario for further analysis and as the subject to show how particular solutions and technologies address various model lifecycle management issues. The presentation is based on the one delivered and very warmly accepted as part of the Vendors Challenge at the INSOS workshop, January 2015. In California. A description of the challenge scenario can be found at OMG Wiki. The session demonstrates model development, model use, model reuse, simulation, and model collaboration. The session will be hosted by Dr. Saulis Pavalkis, Global Customer Support Manager, Analyst, and owner of the Newcomer Requirements Modeler product at NoMagic. If you have any questions during this presentation, please ask them in the chat window. After the presentation, Saulis will answer some of them live here. Due to the limited time, other questions will be answered later and published with the link to a video of the recorded webinar. The presentation will take approximately 45 minutes and the question-answer session about 15 minutes. So Saulis, are you ready to start?
Yes, thank you, Renata, for introduction, a very good introduction. And today I will show the sample which we started to make for January in Koza workshop. And there were some kind of vendor challenge, but the challenge was without a winner. And the goal was to show and to make stage for the discussion how each of the vendor deal with model lifecycle management. And the topic which was this challenge was the configurable UAV. So the goal was to present how such kind of factory, which is spread in different countries, would build the UAV, which is configured in the factory based on the client requirements. So we used multiple languages and our products to deal with that challenge in a model-based way. So first of all, we overview the process which we propose for such kind of configurable UAV development. So first of all, we get the order. So order comes from the client. Then we perform features configuration. So basically, together with the client, we configure that future UAV, and that feature configuration is done using UPDM, and UPDM supports the feature configuration, and so that instance of the configuration is then delivered, if approved, then delivered to the design department. And initial assembly project is selected, the project which is most typical for that configuration. There could be multiple configurations, so basically there are different kind of variants of the projects which could be chosen, and from existing experience and previous projects, they choose the one which is most similar. Then they specify conceptual architecture, and if that is approved, then they go to functional architecture. Then they select physical blocks, physical components from blocks library, and then they specify physical architecture. And then they perform analysis. So basically, we perform trade-off analysis in this sample based on the government regulations which are applied for this particular order of configurable UAV. And for trade-off analysis, we use simulation, SysML parametric diagram and camera simulation toolkit to execute it. For all the approvals after each stage, we use web reporting, and that web reporting is based on the configurable views and viewpoints based templates and new product Cameo Collaborator, which allows to review and approve documents. And for all the design, we use SysML and Cameo Systems Modeler. And for collaborative work between different team members, we use Magic Draw Teamwork Server and with different user rights. So first of all, we took the project from Teamwork Server. So here we can see it. We were logged in, we log into Teamwork Server and check out the project. And now here we can see the project. So basically, first of all, we imported user needs. We get user needs as Excel document. And here we can see that Excel document. It was included in the project. Now you can do that. You can just drag and drop the project to the browser and it will be included. The file of Excel will be included, or any kind of other files. And but we need to have those user needs as business requirements. So basically, the most simple way is just to copy paste them. So we did that already, but let's do that. Some changes in order to see that even the changes can be imported in that way. And you can see that we were requested to choose what kind of requirement to create here. So let's choose simple requirement. And you can see that 0 requirements were created, 7 updated, and 0 failed. So basically, we see that this requirement was updated with a new value, text value. So from user needs, we move to our typical features. So first of all, we have capabilities which our configurable UAV supports. So we have serving in support on agricultural missions, long-term loitering, search and rescue support, and we map those capabilities to features, and we have different variation points in our case. So here you can see that propulsion can be electric engine, hybrid engine, jet engine, gas engine, and this is representation in the diagram, and this is the representation in the table format. So basically we have control units, different variants of that, fuel tank, low capacity, high capacity, and then we have sensor package, Chalmers sensor, satellite sensor, and so on. And then based on the capabilities, typical configurations of a configurable UAV for different purposes are created. So here we can see that those typical configurations. So basically we have configurable unmanned aerial vehicle, just the typical one, and then we have the configuration for surveying in support on agriculture missions, long-term loitering, search and rescue, military search and rescue. So based on typical configurations, actual configuration is created. So now we will go to actual configurations part, and we will create actual configuration that should be typical for our needs, because we don't have such kind of typical configuration. And each new configuration is created by inheriting from existing configuration and redefining required features or specifying possible number of features or eliminating them. So now let's go to the actual configuration part, and here we can see that we inherited most suitable typical configuration and created actual configuration. So we can do that right now. So basically what we do, we name the configuration. Then we go to attributes and we choose required configuration. For example, main unit, so we need not 2 units as here main alternative, but we need just 1. So what we will do, we redefine it, we rename it, that will be the just main unit, and we will specify multiplicity to 1. Then we will choose propulsion, and in our case that should be gas engine. And then we will choose tank, and in our case the tank is high capacity. So we created configuration, and once we did that, based on our created configuration, each instance of actual configuration is created, which is delivered to design department. So in order to create instance, we go to the tools, create instance, and now we can create the instance of our configuration. So an instance creation required number of features is selected, required features and required features are selected. So let's for ground control, we can choose so basically satellite GPS, and then we can add another feature. Pilot operated mobile control. And then for sensors, we will choose satellite sensor, and we will add one more sensor. You can see that here is the multiplicity, which allows us to add up to 4 sensors, so we can add from 1 to 4 sensors. And thermal sensor, it's quite good for research and rescue operations. And here we can't change anything. We basically have the required tank, then we have control unit, then we have software package, and we have propulsion gas engine. So next, and we will choose where to create our actual instance of our configuration. We will name that package order. Next, and we will place that information here, and our order is created. So basically we can represent it in the diagram form, but also we can represent it in the tabular form, which shows what kind of sensors, what kind of control units were chosen. And this order is delivered based on created and delivered to design department configuration instance. The most typical configurable AV design project is selected and adapted to current client needs. So system design starts from system context specification. So basically product interaction type is specified. So here we have our product and we have everyone who deals with that products interact, and the interaction behavior is also specified in our case. So here we can see the communication between operator and UAV for target identification. And glossary is constantly updated, and it has all the terms which are specific for this project. So here we can see the glossary of terms, and you can see that terms are underlined, and once you put mouse over the term, the definition is shown. Also you get that term as auto-completion, for example, environment, and you can choose, and it will be added automatically because all the glossary terms are suggested on typing, so you will not make any mistake. And you can turn off the glossary support from the glossary, and here you can see that all the underlined terms are not underlined anymore. So let's leave glossary, turn it on. And then system requirements based on user needs are specified. So here we can see the system requirements, and they are specified, and here type of the system requirements is specified also. So performance, functional, and so on. And also we have the governmental regulation requirement that we are going to deliver this UAV to the country where UAVs can't exceed the weight of 330 kilograms. And here we have the same requirements represented in the table format. And here we can see the owners, so functional, security, usability, performance, governmental. And mapping from user needs to system requirements is created. It's important that to validate that all user needs are covered. So here we can see that mapping. And based on system requirements, use cases are identified. So here we can see the use cases, and each use case scenario is specified, all functions of system identified. So we can double click and see that the use cases are described with activities, and each use case scenario step is separate activity, and it's allocated to a block and structural block. And here we can see that one activity is not allocated, and the validation checks that, and we can solve that problem, allocate to behavior. And we can see that that allocation is basically automatic. Once you have swim lanes and add new activities, actions, they are automatically, activities are created automatically and allocated to the block gas engine in this case. So based on next step is based on the function product structure, parts are created. Here we can see configurable UAV, and system components are also identified, interfaces identified. So here we can see gas engine, and structure of gas engine is also specified. Power management unit, engine control. And based on logical module, physical module is created. So in our case, product 3 is created, and product 3 is created from a components library, which we have in separate project. And we can see here the project, it's used in our assembly project, and it has such kind of components as engine. Here we can see gas engine, and also we have here hybrid engine. And also we we specify design alternatives in order to calculate trade-offs and the suitable for us design. So here we have 3 alternatives for our design. So first of all, we used a gas engine, which is a little bit heavy. And then we specified alternative 2, which uses smaller fuel tank. And then we specified alternative 3, which uses lighter hybrid engine instead of gas engine. And design alternatives are created by inheriting from product 3 and redefining required properties. So we redefined engine and tank in our case. And here we can see that we wanted to test with trade-offs the corresponding is our design corresponds to governmental regulation, and we had governmental regulation that weight of configurable UAV in this country can't exceed 330 kilograms. And that regulation moved to system requirements that total mass shall not exceed 330 kilograms, and then we formalized this requirement with constraint block. So we put that constraint that total weight can't be more than 330, and then in the design we checked the total mass and also we checked the mass margin. And now we can simulate this and see that our design corresponds with government regulation. So basically, if that government regulation would change, that would not require to change our design, just we would see that it not fit and maybe some other alternative needs to be created, or maybe some other alternative is already suits us here. And here we calculate mass limit in parametric diagram, and here we calculate mass margin in parametric diagram. And now we will run the simulation. So in order to run the simulation, just have camera simulation toolkit installed, and once we run the simulation, we see that total mass is red, and on mouse over we see what requirement is not met. So total mass shall not exceed 330 kilograms, and it is not satisfied, so in requirement number 28. And also we see that mass margin is -5 kilograms. And now we can check alternative 2. And we can see that requirement is satisfied. Mass margin is 45 kilograms. So we have a lot of unused weight. And then we can check our other alternative. And here we can see this mass margin is 5 kilograms, still okay in our case. So both alternatives are okay. So basically we covered user needs, features, typical, actual, then we covered conceptual modeling, system requirements, glossary, context, the governmental regulation, which were the mass limit. Then we went to logical model, then subsystem requirements, functions, which were specified with use cases and activities, then the structure, the structure of the product, and then mass limit requirement, and then physical model. We had product 3, which were built with components, physical components from the physical library, and here is this physical library, and then the alternatives design and calculation. And next thing which we want to talk is about configuration management. So once we had the request coming from the client, so we initiated feature configuration project, and we created our actual configuration. So this is the separate project basically in Teamwork Server. So you branch it and you create your own configuration. And then we have another project, which is an assembly project, which is used by designers. And this project uses actual features configuration specification project. So basically once it is done with typical configuration specification, it is moved and the suitable assembly project is branched, and the feature configuration project is used as used project in that project. And also the assembly project is using physical components library. So all the and components library uses component projects. So each component has its own life cycle, and it can be developed, and once it is approved, it's moved to physical components library. But all those usages are not the latest version usages, they are sticky version usages, because everything needs to be approved, and you don't want that library would change in your project once you do that project. You may want that library would change once you will have new project, unless you will be notified and you will approve that change and so on. So basically we have those different projects in Teamwork Server, and the actual configuration looks like that. So here is the actual exported configuration from Teamwork Server using project usage map. So here we have assembly project, different branches of the assembly project. So assembly projects for surveying and support on agricultural missions, search and rescue support, long-term loitering, and all of them using feature management project, and also using physical blocks library, which has the engine and interfaces. Let's close this, switch to the previous project. Also we can check those usages right in the Teamwork Server. So current project, and here we can see those usages. So we don't need those profiles which comes like doc book library in our case. We just need to see that we are using with our current configuration project assembly 456 the features management project, and then physical library which is using those components, and they have common project with interfaces. So next step is an analysis. So everywhere we created and moved from one stage to another, we created also the traceability. But first of all, in order to create traceability and track it and use it, you need to specify what kind of traceability relations do you need. So you create a traceability scheme or meta model, and in our case it's also specified. So we have user needs covered with business requirement, then we have conceptual model system requirements, and that's extended requirements which is used for them. Then we have logical model subsystem requirements, and then extended requirements is used for them. Then logical model functions activities and logical model structure blocks, and then logical model, this is physical model, and it's also blocks. Everywhere we create the traceability matrices, which shows the relation, and here we specify the relation. So here we use the derivation, here we use satisfy, allocate, trace. And here are those traceability matrices, which once we have the traceability meta model or scheme, we know what relations to create in the model, and we know what kind of matrices to create, and those matrices show us relations and updates automatically. And then we can create multi-level traceability maps using relation maps. So here we can see from requirement to derived requirements, and then to the functions, and then to the conceptual model, logical model structure. And then we can calculate metrics also. So in our case, we calculate metrics and we see that requirements, logical requirements are covered. So here we can see that we have in logical state we have 11 requirements and 7 of them are covered. And we can recalculate new metric and see that that hasn't changed. And we can go back to our traceability map and see the requirements coverage, and we can validate and see that those requirements are not covered, and we can run validation and see track which requirements are not covered. So we choose the validation, completeness validation suite, which we are using in our project, which is predefined for our needs. We choose that we will validate, check this part of the model, and we see the requirements which are not covered. If we would create here requirements coverage, we see that validation updates, and this is not live validation, it's on-demand validation. We see that validation updates, and also we can recalculate the metrics, and also we see that the metric shows that now there are more requirements covered. Next thing to show is the change management, and we now implement the suspect links. So the concept of suspect links came from requirement management products, and they are using suspect link to show the link which is the requirement in most cases which was updated. But once the requirement is updated, it needs to be verified that this update does not affect other parts, or the other parts related modeling parts, design, test cases, and so on needs to be maybe changed after this requirement update. So once we have any update of requirement, we need to have that identified quite clearly for all other team members. Those are responsible for design, those are responsible for test cases, that they need to review that update and to check that the parts are also suitable after that update. And in general, the solution is to have suspect links. So if you update requirement, the relations which are incoming into that requirement should become suspect. And everyone who is also using those requirements and who is owner of those relations would see that they are suspect, and they would accept those changes once they do the update or review of the parts of the model. So here we can go and see how that works. So basically we are working on this part, and we just have this solution in alpha version, but the real version is coming soon. Let's go to the stability model, and here we can see requirements, and let's change some of the user needs. So for example, this one. Or basically, you can remember that we have already changed one user need once we imported from Excel the data. And so now you can see that this is something is different in this part. We can see here that we can see two changes. So requirement text has changed from this to this one. And also we see another change, and this is because we have two derived requirements from this user need. So basically each relation needs to be overviewed by might need to be overviewed by separate persons. So basically we will have as much suspect links as relations are, even the change was one. And now we can deal with that suspect link. We can accept the change, or we can see the usages, and basically if we will accept the change, that link will become normal again. So let's do that. And also let's do that with this link, accept the change. If we would change this requirement again or some other requirement again, let's say we will change the name, not the text in this case, we will see that relation would become suspect. Here again, the requirement name has changed. And so the same thing would go with satisfy, with verify, other relations, refine, and so on. So last but not least, once we have, according to our process, the ready documentation, we need to publish it. And for publishing, we use new product Cameo Collaborator. In all those stages, we publish the document online to our web server. And for publishing, we are using tools published to Cameo Collaborator. And this will publish to the web server. And here we have the project opened in from Cameo Collaborator server. And here you can see the same view as we had in the model, in the product. And you can start the workflow in order to assign the task to review and approve the required the produced stage of the model. So in order to do that, you can go to the task, workflows, start workflow, choose the workflow. The workflow is predefined. You can choose create your own. Set the due date, priority, select reviewers, choose required approve percentage, add items, so in our case it's this project, and then start workflow and send. So basically the notification will be sent to the assignee. And now let's log in with the Peter. And Peter can see my tasks, and he just got one task which is due date June 13, and he can go and review this model. So here he would click, and he would get the model and would be able to comment on it graphically on text, and also once he did that, he can change the status, for example, in progress, completed, approved. So basically what we need to approve that he would approve this this task, and he did that. And now that we get notification that the stage of the model which we required to approve was approved, and no documentation needs to be created, text-based documentation needs to be created. Everything goes online using the Cameo Collaborator. And we can log in back, and we would see that it was reviewed and approved. and we can see the project. And if the Peter would add any comments, we would see them here, including the graphical comments, like that. So basically that's all what we wanted to show you today. And now I'm switching to Renata and to the questions and answer session.
Thank you, Saulis. Thank you for an interesting presentation. We already have a few questions. So the first one is very practical. Will this project that you're using now be available to download and study?
Yeah, so we find out from our clients that the projects which we are using for webinars are also the thing which required to share. So we will do that together with recording. We will share this project also.
Okay, thank you. When do you plan to support suspect links?
So it's an alpha version, and right now we are doing research and analysis, and if everything will go fine, so in let's say 90% that we will have that in next versions 18.3.
What are your plans for variant modeling?
So right now this is also in the research and analysis phase. Very good question, because it's a very broad topic, and basically we are collaborating with partners, with vendors for variance modeling support, and the topic of variance modeling is quite broad. You can have the design variance, and then you can have the product line engineering. So we are trying to find out what's the first stage to support, and we for sure want to have the design variance support, right design variance support. We are looking also for the product line engineering support, and we are looking also for the standards which would allow us to support this. But also we know that there are companies which are quite good in this part, and we would like to collaborate with them, and we are talking with them, and we are planning to have also, we are not excluding the integrations, and that could be joint solution which would be beneficial for them and for us, and for to have that common solution, integrated solution for product line engineering.
We have one more question. What kinds of templates are supported by Cameo Collaborator at the moment?
So Cameo Collaborator allows customizable view and viewpoints templates. This is very powerful solution because those templates are really flexible. You saw that the model looks like it is in the Cameo Enterprise architecture which we're using for modeling. But also you can have different views. So basically you can go here and see what kind of templates are right now. So we have business process, entire model. So we were using entire model template which published the project as it was in the containment tree. But we also have predefined template for requirements, which has 118 views, so you can imagine how flexible it is. And then we have software engineering, and we have SysML, and also we are working on UPDM template.
Thank you everyone for participating today. Thank you, Saulis, for the presentation and your explicit answers.
Thank you, Renata, for helping me today.
Thank you. You're welcome. If there's anything we didn't cover today, please do not hesitate to contact us with your questions at any time. We appreciate your feedback and consider it when improving our webinars. So thank you again, and we hope to meet you in the upcoming webinars.
Yeah, and I could say that we will have recording of this webinar on our website, and it will be something in a week, and also we will put this project, and we will see you in the second part of the year, which will have also the series of webinars. Thank you very much.
Thank you.